Hello and welcome to today's class. So today we'll be dealing on differentiation of trigonometric functions. Differentiation of trigonometric functions. Now, assuming this is y, and then we are asked to differentiate y with respect to x, which is dy all over dx. And then first of all, we have sine x, and we have to differentiate sine x. So if we differentiate sine x, it would give us cos x. If we are to differentiate cos x, it would give us negative sine x. If we differentiate tan x, it would give us sec squared x. If we differentiate cot x, it would give us negative cosec squared x. If we differentiate sec x, it would give us sec x tan x. And then finally, if we differentiate cosec x, it would give us negative cosec x cot x. Now let's take an example. Example 1. If y equals sine of log x, and we are asked to find dy all over dx, how do we go about it? So we will be using chain rule to solve this problem. And the formula for chain rule is dy all over dx equals dy all over du multiplied by du all over dx. So we have y. So what is needed now is u. From the question, u equals log x. Remember, when you are asked to solve any problem using chain rule, u is what is inside the bracket or the term in the bracket. Since y equals sine of log x and u equals log x, therefore y equals sine u. Now, dy all over du equals, if you differentiate sine u with respect to u, it would give you cos u. Let us check the table again. From the table, if you differentiate sine x with respect to x, it will give you cos x. Therefore, if you differentiate sine u with respect to u, it will give you cos u. Now, let's substitute the calculated parameters into chain rule formula. Chain rule formula is dy all over dx equals dy all over du multiplied by du all over dx. So substituting, we have dy all over du is cos u multiplied by du all over dx gave us 1 all over x. So if you multiply through, it would give you cos u all over x. But u equals log x. Therefore, let's substitute the value of u into the equation. Dy all over dx equals cos log x all over x. Now let's take another example. Example 2. If y equals sine 4 plus exponential 3x, find dy all over dx. Now, u equals 4 plus exponential 3x. Therefore, du all over dx equals, if you differentiate 4 with respect to x, it gives you 0 plus, if you differentiate exponential 3x with respect to x, it will give you 3 exponential 3x. Since y equals sine 4 plus exponential 3x and u equals 4 plus exponential 3x. Therefore, y equals sine u. Now, if you differentiate y with respect to u, remember y equals sine u, and if you differentiate sine u, it would give you cos u. Now let's apply the chain rule formula. Chain rule formula is dy all over dx equals dy all over du multiplied by du all over dx. If you substitute into the chain rule formula, it will give you dy all over dx equals dy all over du gave us cos u multiplied by du all over dx gave us 3 exponential 3x. So we have 3 exponential 3x multiplied by cos u. But u equals 4 plus exponential 3x. Now let's substitute the value of u into this. So dy all over dx equals 3 exponential 3x cos x, open bracket, 4 plus exponential 3x. Now let's take the final example. Example 3. If y equals tan 3 exponential 3x, and we are asked to find dy all over dx, how do we go about it? The first thing is to identify your u. So u equals 3 exponential 3x. Therefore, du all over dx equals, if you differentiate 3 exponential 3x with respect to x, it would give you 9 exponential 3x. Since y equals tan 3 exponential 3x and u equals 3 exponential 3x, therefore y equals tan u. If you differentiate y with respect to u, it would give you, if you differentiate tan u with respect to u, it would give you sec squared u. Now let's check the table for confirmation. So from the table, if you differentiate tan x, it will give you sec squared x. Therefore, if you differentiate tan u, it would also give you sec squared u. Now let's apply the chain rule formula. And chain rule formula is dy all over dx equals dy all over du multiplied by du all over dx. So now let's substitute into the chain rule formula. Dy all over du gave us sec squared u multiplied by du all over dx gave us 9 exponential 3x. Therefore, dy all over dx equals, now let's rearrange this. So we have 9 exponential 3x multiplied by sec squared u. But u equals 3 exponential 3x. Substituting the value of u into the equation, we have dy all over dx equals 9 exponential 3x sec squared, open bracket, 3 exponential 3x, close bracket.